Hello, ladies and gentlemen. This is Ms. Backfish, and I am here to talk to you briefly about how to verify a trigonometric identity. Basically, this is a process, and the key thing about it is the process. And so that can make it a little tricky because you have to know what it is you're supposed to do. What am I supposed to do with this? So, for instance, we might have a problem that looks like this, and we're asked, verify the identity. Now, first off, an identity is something that is always true. So that's all that means. An identity, just show that this is always true. No matter what A is, no matter what we're doing, no matter what our specific angle is, it's going to be true for every angle. All right, so the first thing you get is you get an equation. That's your identity. This is equal to this all of the time is the idea. Now, in order to verify the identity, you pick one side of this equation, one side only, and you start with that side only. This is not like solving a regular equation where you write both sides over and over again. You keep writing both sides. With verifying an identity, you start and you pick one side, this side or the other side. Some teachers will have you write LHS for left-hand side and RHS for right-hand side. So you could do that if you want to. But you basically need to pick just one and then rewrite it. What you usually want to choose is you usually want to choose the one that you can see, okay, I can do something with this side. I know that there's something I can do to simplify this, something I can do, maybe another identity I can use to rewrite this. And so here, this tells me I've got something going on here. I can see that it's begging to be distributed maybe. Something like that. So I'm going to start with that side, and then you only write that side. Do not write the other side. Like, that's a big deal. Like, do not do it. Don't write the other side. We're not going to write equals this. Because what we have to do is we're going to start from here and show that just by simplifying this side, or rewriting it in various ways, according to things that we know, that we can get to where we can show it's equal to that. And that's going to be down here at the end. So first I'm just going to take this. There's a lot of ways you could go with this. I'm going to go ahead and distribute first. I'm going to distribute, and I'm going to have tangent of A times the cotangent of A plus tangent of A times the tangent of A. Okay? And then I am going to rewrite, and this is very often something that you do at some point, I'm going to rewrite these different trig functions strictly in terms of sine and cosine. In other words, the tangent is the sine over the cosine. So I'm going to rewrite the whole thing strictly in terms of how does this relate to sine and cosine. And cotangent is cosine over sine. I really am not going to do that here, and I'll show you why. A lot of this is sort of guesswork in terms of where can I go with this. I'm just going to rewrite this for right now as tangent squared. And you're going to see why pretty soon. This, when you have a fraction times its reciprocal, that's just going to be 1. 1 plus tangent squared. Well, there's an identity that says that 1 plus tangent squared is equal to what? It's equal to secant squared. So there we are. We have done it. We have set out to show that this does indeed work out to equal secant squared. So again, if you use the left-hand side, you might start with left-hand side and then work your way to right-hand side. You don't always have to start on the left-hand side. You might want to start on the right-hand side. It might seem like that's the easier side to start with. I would say that more often than not, the way textbook writers and worksheet writers set them up, they set them up so that very often the left-hand side is a good place to start. So if you're, when in doubt, that's a possibility. So if your teacher wants you to write left-hand side, right-hand side, a lot of times you write right-hand side at the end to show you're done. You might do check mark to show you're done. It's sort of a proof, so you might use these double parallel lines or even QED. Those are all ways to show, hey, I've done it. I have shown you what you told me to show you. All right, let's do one more like that. All right, here's another identity we're being asked to verify, or this is something that we're being asked to show that it is an identity. We're trying to show that, yes, this is always true. I can work this out, so to speak. rewrite it, simplify it, etc., and get this, all by doing things that are legal. Okay, one of the things I want to emphasize again is you only work with one side. Only work with one side at a time. You work with one side, and you work with that side until you can show that it's equal to the other side. This is probably another one where I'm going to start with my left-hand side. All right? But when you do that, make sure the very first thing you write needs to be that entire side exactly as it is. You don't start by simplifying. Like, you don't simplify before you rewrite it. Start out just with one of the sides rewritten so that you can show, hey, okay, I'm going to start with this side. This is what I'm going to start as if this is like my given information. Given that this is true, I'm going to show you that this is true. All right, so there's a lot of different ways, things we could do here, ways we could go here. I think when I see a fraction like this that has a binomial or a trinomial, it has more than one term on the top and only one term on the bottom, I think why not split that up, okay? In other words, this is why when we add and subtract fractions we get a common denominator, is because when you have a common denominator, that's the same as 1 over secant plus cosecant over secant. All right? And then the minus cotangent is still here. Now I'm going to go ahead and do that whole let's rewrite things in terms of sine and cosine. As you're doing this, that's a very common strategy. As you're doing this, you do want to keep an eye out for other identities, for sort of things you can shortcut. Like in that last one we did, it was 1 plus tan squared equals secant squared. There's nothing like that here so far that I can see. So I'm going to go ahead and change everything based on cosine and sine. 1 over secant is the cosine. So this is going to be rewritten as cosine. And then cosecant is 1 over sine. And secant is 1 over cosine. And then tangent is cosine over sine. All right. Well, looking at this, I need to figure out how this little fraction simplifies. And remember, when you're dividing fractions, it's first one times the reciprocal of the second one. So in other words, just to the side here, I'm going to say 1 over sine of x divided by 1 over cosine x equals 1 over sine times cosine over 1. So this is going to equal cosine over sine. So that's handy that that's what this equals, because look what's here. So cosine over sine, I'm going to replace that. So I have cosine plus cosine divided by sine minus cosine divided by sine. These two, sorry, it's frozen, it looks like. These two add to 0, and that leaves me with just cosine of x. And I like to draw these to say, hey, I am done. I showed you what you asked me to show you. I showed you that this does indeed work out to be the same as this. Okay, so I just wanted to make sure you saw the protocol there, because really that's what it is protocol. Is what am I supposed to do? What steps do I take? How do I write it in order to correctly show you that this is indeed true? And that's verifying a trigonometric identity. I hope this has helped, and I will see you next time.